Hello everyone, welcome to the Bodhi Academy. In today's PYQ series, we are going to solve PYQs of Class 12 Physics, Chapter 1 Electric Field and Charges. Okay, so let's solve the first question. Two charges of equal magnitude and a distance r exerts force F on each other. If the charges are halved and the distance between them is doubled, then the new force acting on each charge is F by 8, F by 4, 4F or F by 60. So we will solve this by using Coulomb's law. So Coulomb's law states that F is equal to K Q1 by Q2 upon R square. Okay, so this will be F is equal to K Q dot Q upon R square for the first situation. So this will be K Q square upon R square. So in the new situation where the distance is doubled and the charges are half, the first charge will be Q1 by 2 and Q2 by 2 and distance will be 2r. So this is going to be f dash k q by 2 q by 2 upon 2r the whole square. So this will be k q square upon 16r square. So substituting this f in this equation, we will get f dash is equal to 1 upon 16 f. So the answer will be the fourth option, that is f by 60. So let's move on to the next question. 2-point charges plus 3 microcoulomb and plus 8 microcoulomb repel each other with a force of 40 Newton. If a charge of minus 5 microcoulomb is added to each of them, the force between them will become, first option, minus 10 Newton, plus 10 Newton, minus 20 Newton or plus 20 Newton. So here also we will apply Coulomb's law only. So the question says that we will have to add 5 microcoulomb. So the first charge will become 3 microcoulomb plus 5 microcoulomb. This will be minus 2 microcoulomb. And Q2 will be plus 8 microcoulomb plus 6 minus 5 microcoulomb be plus 3 microcoulomb. So F is directly proportional to Q1, Q2. So this is going to be F is equal to Q1, Q2 on Q1, Q2. So this will be minus 2 into 10 raised to minus 6 into plus 3 into 10 raised to minus 6 upon 3 into 10 raised to minus 6 into 8 into 10 raised to minus 6. So the answer to this will be 6 minus 6 upon 24. So this will be 1 by 4. So this is going to give us 1 by 4 into 40. So this will be minus 10 Newton. So the answer will be first option, that is minus 10 Newton. So coming to the third question, a point charge is placed at a distance a by 2 directly above center of a square of side A. The electric flux through the square is. So for cube, the total electric flux is Q by epsilon naught. So for a square, it will be any one side of the cube, any one face of the cube. So as the cube has 6 faces, it will be 1 upon 6 q by epsilon naught. So the answer will be q upon 6 epsilon naught. So coming to the fourth question, a spherical shell of radius 8 centimeter has a large charge of 1.6 into 10 raised to minus 7 coulomb distributed uniformly over its surface. What is the electric field at a point 12 centimeter away from the center of the shell? So since 12 is more than 8 centimeter, it will be outside of the shell. So using the formula E is equal to K Q upon R square, we are going to solve this question. So it will be 1 upon 4 pi epsilon naught Q upon R square. So this will be 9 into 10 raised to 9 into the value of the charge will be 1.6 into 10 raised to minus 7 upon r square, that is the total distance. So it will be 0.12 into square. So solving this, we will get 144 into 10 raised to 2 upon 0.0144. So this is going to give us 1 into 10 raised to 5 Newton per Coulomb. So this is the answer. So coming to the fifth question, with the help of a neat diagram, derive an expression for electric field at any point on the equatorial line of an electric dipole. So the question has two parts. The first part is drawing the diagram and second part is deriving the expression for electric field at any point on the equatorial line. So the diagram will be the dipole, so the dipole having plus q and minus q charges, and the distance between them will be 2a, and the dipole moment will be p, and the electric field at point p at equatorial line, it will be divided into two components, that is E sin theta, E cos theta, and the distance will be root r square plus a square, and we have derived this using the Pythagoras theorem. So electric field at point P due to minus Q charge will be electric field formula 1 upon 4 pi epsilon naught Q upon AP square. So AP square is R square plus A square. So this will be 1 upon 4 pi epsilon naught. The root will be cancelled out due to AP square. So same way, electric field at point P due to plus Q will be 1 upon 4 pi epsilon naught Q upon BP square. So same way, the answer will be 1 upon 4 pi epsilon naught Q R square plus A square. So we notice that both these magnitudes will be same. So magnitude of the charges are equal. So we can write the electric field by taking the modulus. Why modulus? Because the charges are opposite. So it will be 1 upon 4 pi epsilon naught q r square upon r square plus a square. The sine components will be cancelled out and it will be the cos component which is considered. So that will be added up. So taking that into consideration, it will be E, that is electric field, equal to minus E Q cos theta and plus Q cos theta, taking cos of minus Q charge and plus Q charge. Since both the charges are equal, it will be E minus 2 E cos theta of any one charge. So that will be taking the cos theta, that is opposite, adjacent upon hypotenuse, that will be A upon root of I square plus A square. Substituting that value here, it will be minus 2 1 upon 4 pi epsilon naught q upon I square plus A square into, substituting the value of cos here, that will be A root of uh, I square plus A square, and taking the vector P. So, solving this, we will get 1 upon 4 pi epsilon naught 2aq I square plus A square upon 3 by 2. Why 3 by 2? Because this is I square plus A square raised to half and this is raised to 1. So, adding both of them, we will get 3 by 2. So, that will give us E equal to 1 upon 4 pi epsilon naught P. Why P? Because 2aq is the formula for dipole moment, that is P. So that is R square plus A square raised to 3 by 2. Now for short dipoles, it will be the A will be neglected because the distance will be more compared to the length of the dipole. So that will be 1 upon 4 pi epsilon naught. The A will not be considered, so that will be R cube. So that is the derivation. So let's move on to the next question. Derive the expression for the torque acting on an electric dipole placed in an uniform electric field. So we have to derive expression for torque. Torque is basically rotational equivalent force. We have learnt about torque in 11th standard as well. So we have to derive a expression for torque acting on an electric dipole in uniform electric field. So diagram is, the line represent the uniform electric field. So dipole, that is minus q plus q, distance between them is 2a, and the electric field is divided into two components, 2a sin theta and 2a cos theta. So the force acting will be on plus q, it will be this direction, plus q, F plus q, and this will be F minus q, because the electric field's direction is towards this side. So the force acting on minus q will be this side and force acting on plus q will be towards our right. So the dipole moment is given as P is equal to 2A into Q. So the electric field, electrostatic force acting on minus Q due to electric field is given as F minus Q equal to minus Q E. Similarly, for plus Q, it will be force acting on positive charge equal to plus Q E. So the total force acting on this will be 0, because minus Q and plus Q will get cancelled and it will be 0. So it does not experience any net force, but it will experience torque. So torque is given as either force, so any one of the forces, into perpendicular distance between two charges. So this is an important formula. So this will be given as QE 2A sin theta. So we have seen that Q2A is equal to P. So we have substituted this here. So P is torque, that is tau, is equal to P E sin theta. So we can write this in the form of vector, and because it is divided into sine and cos, we can do the cross product. So tau is equal to P cross E. So when theta is 180 degree, that means when the dipole is horizontal, it will be 0, because the sine will be 0. Sine for 180 as well as 0 degree, it will be 0. So the torque experienced will be minimum. But when the theta is 90 degree, that is when the dipole is perpendicular to the electric field, it will be 1, wherein tau will be maximum. So tau will be 1. So maximum torque will be experienced by the dipole. So that's it with the question. So coming to the next question, the figure shows four positively charged particles and a Gaussian surface encloses Q1 and Q2. So the first sub question is what is the electric flux through the Gaussian surface, and B is what which of the particles shown contribute to the electric field at point P on the surface. So according to Gauss's law, the electric flux will be uh, Q inside upon E naught. So this is permittivity. This is charges, sum of charges inside the Gaussian surface. So that will be Q1 plus Q2 upon E epsilon. And coming to the second part of the question, that is which of the particles shown contribute to the electric field. So the answer is all the particles, that is Q1, Q2, Q3, Q4 will contribute to the electric field because it is irrespective of whether it is enclosed in a Gaussian surface or outside of the Gaussian surface, because point P lies uh, on the on the surface of the Gaussian surface. So that's why all the charges will contribute to the electric field. So that's it with the answer. So coming to the eighth question, the figure shows an electric dipole placed along x-axis in an external non-uniform electric field, increasing in the positive x direction. So what is the direction of the force experienced by the charge minus q, and what is the direction of force experienced by the dipole? So the minus q charge is lying here to the right, and it is plus q. We are given, it is given that the electric field is this side, and minus q, that is the negative charge, which always experience force opposite to the electric field. So that will be in the negative x direction. So answer to the first question is negative x direction. And coming to the second question, what is the direction of force experienced by the dipole? So we know that the electric field is non-uniform, so the net force will be experienced, and E increases in the positive x direction that is given in the question. So force is more on the positive q direction due to strong electric field. So that will be positive x direction. So the answer will be positive x direction. So coming to the ninth question, the distance between charges F into 10 raised to minus 11 Coulomb and minus 2.7 into 10 raised to minus 11 Coulomb is 0.2 meter. What will be the distance at which a third charge should be placed in order to that it will not experience any force along the line joining the two charges? So for a charge to experience zero net force, the magnitude of force exerted by Q1 and Q2 must be equal and opposite so that it cancels out. So Q1 and Q2, the distance is 0.2 meters. So Q3 shall be placed towards the left of Q1. Then the distance, let the distance between Q1 and Q3 be x. So distance from Q1 is x, and distance from Q2, that is Q2, will be x plus 0.2. So for net force to be 0, the force should be equal on experience should be equal on Q3, that is by Q1 and Q2. So this will be K Q1 Q3 upon x square is equal to K Q2 Q3 upon x plus 0.2 square. Because K and Q3 are on both sides, it will get cancelled. So it will be Q1 upon x square, Q2 x plus 0.2 square. So now we will substitute the values. So that will be 5 into 10 raised to minus 11 equal to 2.7 into 10 raised to minus 11 upon x plus 0.2 the whole square, and this will be x square. So cross multiplying and cancelling the similar values, minus 11 and minus 10 raised to minus 11 will get cancelled because it is present on both the sides. So cross multiplying we will get 5 x plus 0.2 the whole square, and here we will get 2.7 x square. So expanding this by using a plus b the whole square formula, we will get x square plus 0.4x plus 0.04. Here it will be same. So after multiplying 5 to each and every term in the bracket, we will get 5x square plus 2x plus 0.2, and this will be 2.7x square. So bringing this 2.7x square here, and it will get subtracted, so it will be 2.3 x square plus 2x plus 0.2. So this is a quadratic equation, so we will have to solve this quadratic equation using the quadratic formula, that is x equal to minus b plus or minus b square minus 4ac, and we will get the answer. So that will be substituting all the values, we will get root of 2.16. Root of 2.16 is close to 1.4697. So we have to find the roots for both the situation, minus 2 plus 1.4697 and minus 1.4697. For plus, it will be minus 0.115 meter, and for negative 1.467, it will be 0.7532 meters. So we will have to discard this more negative value, so the answer will be 0.115 meter. Why discarding this value? Because if we choose this value, the point will be between the two charges, so we have to discard this value, and it will be 0.115 meters. So coming to the last question, derive an expression for the electric field due to a point charge. Also state the direction and nature of the field. So we consider a positive charge at origin, that is O, and we consider a test charge Q0 at point B, placed at distance r from the origin. So according to Coulomb's law, force is equal to 1 upon 4 pi epsilon naught Q1 Q naught upon r square. This is the electrostatic force experienced at point P. So electric field, the formula for electric field is equal to force upon Q naught. Q naught is the test charge. So that is 1 upon 4 pi epsilon naught Q positive Q naught upon r square. The same formula is substituted here upon Q naught. So this Q naught will get cancelled, and it will be E is equal to 1 upon 4 pi epsilon naught positive charge upon r square, or whichever charge you are taking into consideration, that will be the magnitude of that charge will be placed here upon the distance, the square of the distance. So that will be E is equal to 1 upon 4 pi epsilon naught can be written in the form of K and Q upon r square. So the nature and direction of the charge. So if the charge is positive, the nature of the electric field will be repulsive, and it will be directed outwards. And if it is negative, it will be directed inwards, and the nature will be attractive. So thank you for watching today's video. Don't forget to like, share and subscribe to the Bodhi Academy. Thank you.